Hello class, in this video I will be showing you how to find the domain of a composite function. Let's begin. Alright, so in example 16 we have the same two functions as we did in example 15. And they are f of x is equal to 3 divided by x plus 1 and h of x is equal to the square root of 1 minus x. And I'd like to find the domain of h composed of f of x. Now to do that I'm going to start by creating the composite function. So h composed of f of x is equal to h evaluated at f of x, which is equal to the square root of 1 minus 3 divided by x plus 1. Now recall, to subtract fractions we need a common denominator. So this is going to equal the square root of x plus 1 divided by x plus 1 minus 3 divided by x plus 1. And now that we have common denominators, we can subtract. So this is equal to the square root of x minus 2 divided by x plus 1. All right, now to find the domain of this composite function. I'm going to start by finding the domain of f. And I'm going to call the domain of f A. And the domain of f is all real numbers except x is equal to -1. All right, now I'm going to find the domain of the square root of x minus 2 divided by x plus 1. And we're going to call this b. Okay, so this one's a little more tricky than the domain of f. So I'm going to start with the fact that this is a square root function. And when you have a square root function, that means x minus 2 divided by x plus 1 must be greater than or equal to 0. All right, so when dividing two numbers, there's two ways to get a positive answer. The first way to get a positive answer is if the numerator is positive and the denominator is positive. The other way to get a positive answer from dividing two numbers is if the numerator is negative and the denominator is also negative. Okay, so I'm going to start by solving the inequalities on the left. So if x minus 2 is greater than or equal to 0, that implies that x is greater than or equal to 2. If x plus 1 is greater than 0, then x is greater than -1. And since 2 is already greater than -1, I'm going to select that inequality. The x is greater than or equal to 2. For the inequalities on the right, if x minus 2 is less than or equal to 0, then x is less than or equal to 2. And if x plus 1 is less than 0, then x is less than -1. And since -1 is already less than 2, I'm going to choose this inequality. So the domain for the square root of x minus 2 divided by x plus 1 is x is greater than or equal to 2 or x is less than -1. Okay, so now that I have the domain of f of x, which I'm calling a, and I have the domain of the square root of x minus 2 divided by x plus 1, which is b, I can find the domain of the composite function. I'm going to do that by creating a number line. Okay, so the domain of f is all real numbers except -1. So I'm going to place a -1 right here. I'm going to have an open circle, arrow to the left, and an arrow to the right. The domain of B, the domain of the square root of x minus 2 divided by x plus 1 is x is greater than or equal to 2. So I'm going to put the 2 here, closed circle, an arrow to the right, or x is strictly less than -1. So I'm going to place an open circle over -1 and place an arrow to the left. The intersection is everything that I'm highlighting. Notice I did not highlight the 2 open circles. And then here. And notice I did highlight the closed circle. I highlighted the closed circle because 2 is part of the domain. I didn't highlight the open circles because -1 is not part of the domain. So A intersect B is equal to -infinity to -1, union 2 to infinity. Okay, now that we have the intersection of the 2 domains, we could state the domain of the composite function. So h composed of f of x is equal to the square root of x minus 2 divided by x plus 1, and the domain of the composite function is -infinity to -1, union 2 to infinity. And we are done.